Hello, everybody. I'm going to look at you right now because I'm going to start looking just at the laptop after I start. I'm just that much of an introvert, so don't mind me. So the title of my talk is Exploring Progress, the Evolution and Impact of the ALS Research Collaborative, because that is exactly what we'll be doing in the spirit of reflecting back on 25 years of ALS TDI. So fun fact about me, I've never used ChatGPT before, so I thought I would do so here because I was agonizing over reusing a joke, and it said I could, and I should consider adding a twist or update to keep it fresh. So last year, I talked about ARC in context of the precision medicine program, because that's what it used to be, and I used this image to simply convey that ARC was an evolution of the PMP, and I may have limited my audience, so to add a twist, there's that. There's that. I hope some of you feel more included. I don't know that stuff, so great. I'm going to stick with my Pokemon for this. So the PMP launched in September 2014, and it was mostly a remote natural history study, which was designed to collect a large amount of information about the natural progression of ALS. And initially, it was aimed to recruit about 30 people, but the Ice Bucket Challenge helped us get resources to recruit 300. And then over a few more years of the program continuing to grow, we expanded the recruitment goal to 1,000 participants. And the aims of the PMP were to find new targets relative to ALS subtypes. So things like people with SOD1 mutations, or maybe like fast progressors with limb onset. And another aim is to develop new models and test potential therapeutics. Doctors Kyle Denton and Theo Hatzipetros already talked about this a lot. And then lastly, to discover or validate biomarkers to monitor progression. So that could be things like blood neurofilament levels, or maybe speech tracking. Fast forward to March 2023, which was the launch of ARC. The ARC study continues all of the data collection efforts of the PMP, and we also created a platform called the ARC Data Commons to share de-identified data with the research community. We did recently surpass the 1,000 participant goal we set back then, and now are aiming to recruit another 1,000 participants. And the aims of the ARC study are the same as they were when it was the PMP. I want to take a moment to point out that all the progress that has happened with this program is largely attributed to the amount of time and effort that the participants have put in it. So please be amazed by them as we go through the later slides. To provide some context, I'll be briefly walking through the process of signing up for and participating in ARC. It starts by going to arc.als.net and creating an account. We have pretty broad inclusion criteria. People just need an ALS diagnosis or be a known carrier of an ALS-associated mutation, be 18 years of age or older, and be able to communicate in written English. Once the account is created, people can complete the consent process at their own pace and ask us any questions if needed. It usually takes about 30 minutes to do in one sitting. After a participant consents, they get access to their own portal, which is what you're seeing here on the screen, where most of the study tasks are completed. And like with ChatGPT, I didn't realize how easy it is to just make QR codes these days. So I made a few for the presentation. So here's the QR code for signing up for ARC, if anybody's interested. So as I move through the slides and the data types of ARC, I want you to glance at the timeline on the bottom of each slide that shows when we started collecting that data and the years that either publications or major milestones happened. I won't be going into detail on them, but it's sort of just like a visual aid so you can kind of see when work was happening over the years. For reference, you can see the launch of the PMP in 2014 and launch of ARC in 2023. So first off, we have the ALS Functional Rating Scale Revised, or the ALS FRS-R, or the ALS FRS, or the FRS. I might use any of those acronyms. They all mean the same thing in this context. It is a 12-question assessment of the various common tasks or functions that I've listed here on the right. The ability to do these functions is rated on a whole number scale of 0 to 4. It's a widely accepted measure of disease state and progression, though it comes with some caveats, as I'm sure some of you know at this point. It's a bit subjective, and it is restricted to 0, 1, 2, 3, and 4 as scores. So if you're feeling like a 3.5, you really can't tell us that based on this scale. That being said, it has a very important place in both clinical care and research as a standard measure of ALS. And because the ARC study is aiming to develop new measurements of ALS progression, we use this sort of as a tool to compare new measurements against. The next data type is a multitude of surveys. We want to learn about various topics like family and medical history, medications and supplements people are trying, what industries they've worked in, where they've lived, and so on. There's a gap in understanding of how one's environment and lifestyle might have played a role in triggering or augmenting one's disease, so it's important we collect this information as well. Next is speech tracking, which involves folks calling into our automated phone system once a month and recording a set of 5 phrases, which we then convert into audio files and store. And then in collaboration with researchers at Google, they developed a machine learning model that takes the audio recording, turns it into an image, which is what you're seeing there in the blue and green figure. And the machine learning model basically predicts a score for that recording, and where 4 is still sort of normal speech and 0 is really affected speech. And you will see the data like this on the graph that I'm showing here. But an important point to note about the scoring system is it's not constrained to 0, 1, 2, 3, and 4. You can have 2.2, 3.5. So that gets at that sensitivity point I talked about with the ALS FRS. And participants can see data in their portal on the graph that looks pretty much like this. To capture the limbs, we do activity tracking through accelerometry. So this involves sending 4 of these accelerometer devices to participants' homes 1 week out of each month to wear on their wrists and their ankles. We ask folks to wear them as often as they comfortably can during that week, and that is what we call passive wear time. And also during that week, we do ask them to do a set of prescribed movements on 3 days of that week. So those are coordinated movements. So we're going to call those active wear time. And as you can see here, they're seated arm lifts, leg lifts, and toe touches. And it takes about 8 minutes to do this session. So these accelerometers are measuring acceleration. So the more force you put into the motions, the higher the score will be. And like with the voice scores, there's a graph to represent the data in the participant portal. So this data has a bit of a history. For the first 4 years of the PMP, we actually had one aspect that wasn't remote, which was that some participants could come to Boston and get a skin sample and a DNA sample taken at Mass General Hospital. And we would do whole genome sequencing with the DNA and screen for ALS-associated mutations. And then we'd use the skin samples to generate iPSCs and eventually motor neurons to model ALS. You saw that all of that process talked about during Dr. Denton's talk. But around 2018, we actually had to stop these visits because it ended up being too resource heavy for the amount of people we were recruiting. But in 2019, we were able to start collecting DNA samples again. And we're currently working, like Dr. Denton said, to get the iPSCs out of the blood cells again, which brings me to the next slide, which is remote sample collection. So we started this aspect of the program in 2019. And we partner with a variety of mobile phlebotomy groups to cover a pretty good amount of the US now, and also Ontario. With this program, we can collect blood samples from participants roughly every 3 months and use them for omics analyses. These are the omics, or at least some of them. So we collect samples to do whole genome sequencing once again, to look at RNA levels and protein levels. There's a lot you can investigate with blood samples, and you'll probably see a little bit more about it in the later talks today, so I'm not going to go into any specific details there. The last data type I want to touch on is the option to import electronic health record data. Should a participant choose, they have the option to link their EHRs in the ARC portal. And this was a collaboration with a great group at Unite who had this platform or this capability on their own platform and helped to embed it into the ARC portal. And since we implemented it last year, 39 participants have shared their data so far, and collectively that's 1.6 million data points, which is just an incredible ratio of person to data points. And it's been really exciting because we can capture data that ARC doesn't currently capture, like respiratory measures and imaging. But we also can capture data that we can directly compare to what we have in ARC. So like maybe clinical FRS scores, or if they do blood biomarker work in the clinic, we can see that and compare it to our own. And it's not super straightforward to handle EHR data. It's very messy as raw data. So I want to thank Tanner Dagnalin and his team, and also Danielle Boyce, who's here today, for helping us with this monumental task of handling EHR data. And I should mention that connecting your EHR data to ARC does not connect ARC to EHR data. So it's a one-way street into ARC. Nothing is shared with healthcare providers or anything of the sort. So now that we've gone over all the data types, I can touch on all the progress that has happened recently. If you were looking at the timelines on the previous slides, 2022, 2023, 2024 probably popped up a lot. And that's because we've been doing a lot during those years. So here's just like a small snapshot of those. I'll be highlighting some of them and I'll group them by like the data types as we go through them. So done a lot of sample collection studies. We generated a large proteomics database using the SomaLogic SomaScan platform and shared that data with the Global Neurodegeneration Proteomics Consortium. It's so long. Sorry. At the GNPC. Dr. Farhad Imam will be talking about that later today. We're working with Duke and Dr. Bedlack to investigate IGFBP7, which is a gene that his group recently linked to the patients in his ALS reversals cohort. We're hoping to have a webinar on some findings from the study in November, so keep an eye out for that. We are working with a UK-based group called LifeArc to also investigate the proteomics data, and more specifically MMP9 and TIMP1, which are two proteins whose levels have been shown to be elevated abnormally in various preclinical models of ALS. I think Dr. Paul Wright is here today. I haven't seen him yet, but he's also from, he waved at me, hi. He's gonna be on the panel next. And then with the support of Mitsubishi Tanabe, we did a very large scale study on neurofilament light levels longitudinally for people who have contributed samples. And Dr. Vera will be talking about that in the afternoon. With the survey data, we were awarded by a grant from the CDC to investigate a multitude of potential ALS risk factors. This effort is being spearheaded by Dr. Danielle Boyce and Pat Dolan. Danielle will be providing some insight into the processes that need to happen to handle data of this type later during her talk. And Pat probably doesn't need an introduction, but he's an expert with geographic information systems and has already done a ton for the ALS community. I have to say, these are two of the coolest and smartest people I've had a chance to work with. No offense to my other colleagues. At least this year, they're at the top of my list. So I'm really excited to work with them on this project. Moving forward, Marcin Strykevich and a team out of Dr. James Berry's group at MGH have taken their experience with accelerometry and applied it to our data. There's a lot of work being done here, but there was a preprint earlier this year on some early findings that they had. And what they aim to do is validate some methodology that they had in previous studies, but to also investigate if we can measure specific movements from the passive wear time, so not from the exercises, instead of just general activity. So Marcin was able to detect forearm extension and flexion, and then supination and pronation at various degrees, which on its own is an incredible feat to be able to do that in the amount of data that the accelerometers produce. But one other aspect I wanted to highlight from that study is that when you look at the scores of these movements and the changes from their baseline, all of these motions were detected in greater change from baseline than ALS-FRS scores over time from ALS-FRS baselines, which might mean that we're capturing additional information beyond the FRS, which would be very important, but more work needs to be done here. It's still a preprint. Lastly, we got on the voice recordings. We collaborated with researchers at MIT and Takeda on some of our voice recording data. Liming Wang and her team sought to develop a voice scoring prediction model that goes beyond the one that we developed with Google. This was also a preprint paper that was posted earlier this year, and it's pretty technical, but essentially they tested a whole slew of combinations of models and parameters to do better voice score prediction and landed on one that improves on our model by 4.5%, which doesn't sound big, but getting over 90% accuracy is kind of a big deal. And it only gets harder as you get closer to 100%. I do want to make the point that generally this outcome is kind of what we're looking for by sharing our data publicly and sharing our models publicly, is that other people with more specific skill sets and more expertise can take it and just make it better for the entire community. And they're also sharing this model publicly. It's on GitHub now. So the chain of sharing and improving continues. All right, so this is the home stretch now. We're covered most of the stuff. Keep sitting there and doing what you're doing. Great. All right. I've covered a lot of ground, but I haven't had a chance to talk about how ARC can support the development of clinical trials. So what I've listed here are just some general concepts. Obviously, we have a long history of collecting data remotely And more trials these days are looking to integrate aspects of remote data collection to help reduce patient burden and in some cases cost. So we've been able to provide some lessons learned on that front. It also acts as a source of real-world data, which can be used to help inform things like enrollment criteria or guidance on what endpoints might be best to capture based on the specific trial cohort. And it's also a good study for developing new methodologies that can serve as endpoints, like the voice or accelerometry. And to that point, I wanted to highlight that we're working with some great folks at the Critical Path Institute, which is a nonprofit organization that partners with the FDA, NIH, patients, and other research organizations to accelerate drug development and improve clinical trial methodology. They're helping us evaluate our data for potential use as trial endpoints, as they have experience working with the FDA to determine what information and like what level of validation is needed to go into getting an endpoint to be used in trials. And in fact, they've done work with similar technology in Parkinson's disease with smartwatches here, and the Critical Paths Parkinson's Consortium was involved in this recent letter of support from the FDA to use alpha-synuclein seed amplification as a biomarker for detection of early disease processes in Parkinson's clinical trials. So we're really grateful to have them and their expertise, take a look at our data and see how we can take our metrics to the next step. As you've seen, ARC is continually improving, and so here are some changes we can expect in the next year. I don't have too much time to go into each of these, but please check the recording again or come find me if you want to talk about changes that are coming to ARC in the near future. And if you are a current participant in ARC, feel free to come find me and give me feedback. I won't be offended. I'm just as game to change ARC and improve it for the better, as I'm sure many of you are. For any researchers who are watching, here's the ARC Data Commons link where you can request access, and it'll involve signing a data use agreement to get access to the de-identified data. So takeaways, I hope that you understand that participant data helps guide ALS TDI's drug development efforts and promote collaborations with a variety of experts. ARC has evolved and will continue to with evolving technologies that can help us better understand ALS. And then tools and procedures developed in ARC can be improved on and validated for clinical trial use. With that, I want to thank the current ARC staff pictured here who have kept the program running smoothly over the past year with all this growth that we've had. Josh Berman handles the blood, Aaron handles a lot of the accelerometer and blood scheduling, Joe handles data, Beth handles enrollment, and Sean is our lead developer. And then some past members on the right. But I do want to end on a graph that shows just the amount of contributions that our participants have given us over the years. So on the x-axis is time since September 2014. Y-axis is number of data entries, and it's a log scale. So at the top of the graph, you're looking at like tens of thousands of data points. So I'll just let this play. And if we have time for questions, game. No, we don't have time for questions. Sorry, guys. Come find me later. I'm just going to leave that up.